Okay, hello challengers. Today we are here again in this on this Tuesday at 10 p.m. London time. We are here this weekly live, and today we're going to be talking about mastering Java interviews, a strategic guide for intermediate and senior Java developers. So this is important because back in the days, interview was a lot easier, right? Because we would have to know some Java concepts, some OOP concepts, microservices. We would have to talk about our experiences. But nowadays, it's pretty different, right? Nowadays, we have the algorithms interview, we have the system design interview. So it's quite different. And only knowing about Java, only knowing about microservices, it could not be enough, depending on the companies. Most companies are doing interviews with code challenges and algorithms, and if we don't practice them, we won't be able to pass on those interviews. But the good news is that this is just a skill, and we can practice and we can get better, right? So, other than algorithms, we're going to be discussing all the skills that are important for Java developers and that will be crucial for when we do an interview. So let's start with the core Java fundamentals. So as we briefly discussed here, object-oriented programming is very important. So we need to know about encapsulation, inheritance, polymorphism, abstraction. And it's important to know that it's not only about knowing, right? It's not only about knowing encapsulation. You have to know how to explain, because there are many intermediate or senior developers who are in the interview, and then the interviewer asks, "Oh, what is polymorphism?" And then they don't know how to explain that. And there was interviews here in Ireland where an interviewer asked that to the developer, and he didn't know how to explain what was polymorphism. So we have to be aware that only knowing those things might not be enough. We need to be able to explain those concepts as well. And regarding memory management and JVM architecture, you don't need to be a specialist on JVM, but at least you need to know the basics, like at least the basics, the most important parameters. So, and like rarely would you use that in the market, right? And rarely they would ask you a question in an interview regarding the JVM. But it's a nice to have. It's a nice skill to have as a senior developer. Garbage collection algorithms, like you don't need to know those garbage collection algorithms, but you need to know at least how it works, how the JVM will collect objects that won't be used anymore so that it will save memory. Collections framework and implementation. So basically linked list, array list, vector, hash map, hash set. So all of those most important collections, we need to know what are the differences and in what situation we would use those kind of collections. Generics and type averager. So it doesn't mean that we need to be specialists on that, but at least we need to know like why they exist and how we can create methods where we can use also generics. Exception handling best practices, because we're going to be handling exception all the time when we create our microservices. So in every service we create, we're going to be using that. So Java 8 plus features like lambdas, streams, optional, and I saw many senior developers who didn't know how to use streams. And it really doesn't take a lot of effort, right? Just need to be a little bit curious to understand the streams, optional, lambdas. So it's totally fine, right? Functional interfaces and method references. So in what situation you would use one functional interface, what is a functional interface, what is a method reference, what are the differences between method references and functional interfaces. This is very important when you're doing a Java interview. Sometimes they will ask you when you would use streams or when you would use functional interfaces or method references. They might ask you something related to that. Concurrency and multi-threading. So we need to know the basics in Java, right? Threads versus runnable. So the runnable object is the object we pass the action. The thread is going to be the process running, right? Synchronization, how you can synchronize methods so that they run in a multi-thread environment. Thread local. We also have executors and thread pools. Like in what situation would you use thread pools, virtual threads also. Like if you're using virtual threads, you don't need a thread pool because that would be like using a lot of memory. Computable future, reactive patterns, fork join framework. Like you wouldn't be using that very often in a business project, but at least it's good to know that this exists. I tried that once. It's very complicated, but it's it's just a nice to have. It's not something very likely that people will ask you in an interview. Common concurrency issues, deadlocks, race conditions, thread starvation. It's good to know those concepts. And I'm not saying that you should know that in a Java level. You should know that in the concurrency concept, in the fundamentals. And we also have the Java U2 concurrent package. And you don't really need to know all the classes from this package, but still, it's good to know the main ones at least. Data structures and algorithms. And this is very likely that you're going to get an interview with something related to it. So we're going to be exploring the most important ones. So time and space complexity, that's for sure they're going to ask you. They're going to ask you to create a coding challenge. And during this coding challenge is always the same thing, the same pattern. So basically, if you go straight away to the code without asking any questions or without even a small planning, they might basically reject you just because you did that. So basically, it's better, like if something is not clear, it's better to ask, say, okay, this thing here is not very clear. And before you start coding, it's important to create a small plan. You don't need to overthink or overplan. Just put a few comments, right? Just few lines of comments, just with a small plan. And doesn't even need to be the most optimized algorithm. You can start with the brute force approach. Like at least an algorithm that will work. Doesn't need to be the most performant. It just needs to be an algorithm that will work, right? And when you are solving easy and medium algorithms, there will be patterns that are very recurrent, right? Like you're gonna see lots of those common algorithms patterns, like the 2-pointer sliding window, and there are lots of patterns that are very common on those coding algorithms. And you need to know at least the most important search and sort algorithms. You don't need to memorize all of them. Sometimes, like a company will ask you to do a stupid sorting algorithm. I don't think it proves much. It just proves if you're able to memorize things, right? But the company might ask you, so I would recommend you to at least be able to write the most, at least the quick sort or the merge sort. But you don't need to spend a lot of time on that because it's unlikely that the company will say, oh, create the merge sort. But you have to have an idea. You have to know the complexity, what's the big O notation, what's the space complexity. You need to know those things. tree and graph traversals. So you don't need to be a specialist on that. You just need to know enough to do the basics, right? So you need to know the depth first search and breadth first search algorithms, and like they might give you an exercise, a coding challenge with a graph. And if you don't know graph, zero chance that you'll pass an interview. Sometimes, sometimes they will help you. Sometimes they will even do the algorithm with you. Like if you don't remember, for example, how to create the depth first search or the breadth first search, because sometimes the interviewer will just like you. So this happens a lot, right? And you can do like very simple things like smiling. And it seems very simple, right? And it seems that it doesn't happen, but it happens a lot. If you do the simple action of smiling during an interview, like your chances to pass will increase a lot because the interviewer will see you as someone who is nice to work with. Like the last thing an interviewer wants is that annoying person who doesn't know how to work in a team, right? So doing this small thing like smiling will help you. I know it seems very simple and it might be, oh, Rafael, really? Smiling? Yes, it makes the difference. But obviously, you need to know your stuff, right? If you are just smiling and not don't know anything, then it doesn't work. But it's important to also communicate your thought process in a clear and concise way, right? So, and you have to have a balance here. Like, you can't over communicate, and you have to like speak enough to make your message clear. And like dynamic programming approaches, optimization techniques for Java implementations. So basically here, like if you see that you can use a better data structure for an algorithm, you can use it, right? And okay, so what are those data structures that we need to know? Let's explore them. So we have here arrays. Arrays is the most is the one of the first data structures we learn in college, right? So there are some important concepts to remember here. It's fixed size, continuous memory allocation, which means that if you once you create the array with a fixed size, it will be that size. If you create an array with the size of 10, it's going to be 10, right? And it's O1 for when you need to access an element in the array. For insertion, it's going to be ON because you're going to need to create a new array, right? Depending, like if the array is full and you need to, like if the array has 10 elements and you need to add one more element in this array, you would have to create a new array, and it would require uh, also shifting elements, right? But yeah, and it's memory efficient, but the size is inflexible. Like I said, if you have 10 elements in the array, there's nothing you can do. You have to, if you want more than 10 elements, you have to create a new array. And it's the base for many other data structures. And for linked list, it's a bit different. So it's connected through nodes, right? So they are basically references and pointers. And the good thing about linked list is that it's expandable, right? It's able to so basically in a linked list we are able to extend as much as we want, right? Basically, right? Because we're going to be adding a new pointer, a new reference to this linked list, The access is horrible because it's ON, right? It's not performant. It's not a very performant. And so to access by index or search, it's not good. No wasted space for capacity. And we have single and double linked lists, which means that single lists we could add elements only at the end of the linked list, and double linked list you can add in the beginning and at the end. Stack is very simple. Stack just, it's just imagine a stack of plates, right? We have the last plate on the top. It's last in, first out. So basically you put one plate here, another plate here, another plate here, another plate here. What is the last thing? The last thing is the last plate, right? So the last plate is the first out. So remove the plate from the stack. So it's basically like the real world. It's just a stack, right? You stack something and then remove. Obviously, the one that is in the top because it's the easiest. You wouldn't remove the first one. Like, it would be very difficult, right? So we have the push pop peak operations, and so we have backtracking. We have some things here. We have array versus linked list. For queues, we just have to remember like a normal queue. Like if you are, for example, if you want to pay a bill in the bank, it's very likely that you're going to be in a queue, right? And guess what? The first that arrives in the bank is the first out, right? So it's the first in, first out. FIFO, right? So just remember like a real world queue. That's it. So, and there is in queue, DQ, peak, the operations, right? Those are the core operations. And in Java, we can say those are the main methods. And we can use that for scheduling. The breadth first search algorithm, we use a queue. And there is some variations such as priority queue or DQ. And regarding hash tables, it's a key value storage using hash functions. And the average, in most cases, it's 01 for insertion, deletion, or lookup. So it's very optimized. Hash function quality affects performance. So the better you have your hash function, the more performant you're going to have your hash table will be. Collision, this is quite annoying, right? It's not that easy to do this collision resolution. But anyway, usually the main thing you need to know in interviews is that like key value storage, like to look for a value in a hash table, it's 01. So like sometimes in some situations they might ask you, oh, how can you do a collision resolution? And this is not an easy question. Like you have to study a bit. So, and there's also trees, and trees has a hierarchical structure with the parent, child, and relationships. There is binary trees and n-ary trees, right? You can you can create a tree with as many nodes as you want. Tree traversals, pre-order, in-order, post-order. And there is also binary search tree, ordered for all log n operations. And there is even those red-black trees, but it's very rare also that they would ask you, oh, do a red-black tree. Usually they want to test your capacity of solving problems. They don't want to test if you memorized how to create the red-black tree. Like in most cases, because like it's kind of useless to test if you're able to memorize code. Like you're not like a memorizer, right? You won't. You're not a developer who just memorizes stuff. You have to be a problem solver. That's a lot more useful, right? That's what the companies want. So heaps. So it's this is the complete binary tree with heap property. We have main heap, max heap, and there is priority for scheduling. Yeah, so exactly. It's not about memorizing solutions, but knowing when to apply them. Yeah, exactly. That's the key. So that's why we need to be problem solvers, not to be memorizing solutions, right? And for graphs, there is nodes connected by edges, directed or undirected. So we have adjacency matrix, we have traversals with depth first search and breadth first search, pathfinding Dijkstra. This is not very easy to memorize. It's quite complicated algorithm, but like they might ask you again, but like they would be testing your ability to memorize code, which is not efficient at all. It doesn't test if you're a good problem solver. So I personally don't like those kind of tests when the company will test, oh, do you know the Dijkstra algorithm? Or, oh, do you remember the merge sort? Do you remember the quick sort? Or, oh, do you remember the red-black tree? Implement that for me. I think those tests are useless because it's just testing your capability of memorizing things. So that's my opinion. And connectivity, cycles, topological sorting. And the most important skill that a company should be assessing you is, for example, if you know how to explain the main data structures, this is good, right? Because data structures will help you solve problems to create more performant code. This is valid, in my opinion. Analyzing time and space complexity. So if they will ask you for sure. Big O notation, for sure. They're gonna ask you, oh, what's the complexity? You need to know that. Reasoning about algorithm approaches. So they're gonna ask you, oh, is there a way you can improve? Is there a way you can optimize this algorithm? They're gonna ask you, making performance trade-offs. Sometimes you're gonna have to explain why you chose specific data structure. And well, sometimes I wouldn't say you would need to design custom data structures. Like it could be, but it's quite rare. So basically, if you know those fundamentals, arrays, linked lists, stacks, queues, hash tables, trees, heaps, like heaps, it's not even that required. But if you know at least trees and graphs, you should be able to solve the majority of the problems. And if you're able to explain the complexity, why you chose this data structure over the other, that's amazing. That's what they should be expecting from you. It's not if you memorize 1 million algorithms. That proves nothing. Like if you're able to solve problems or not. So design patterns in architecture, it's important to know them. So creational patterns like singleton, factory, builder, structural patterns like adapter, decorator, and proxy, behavioral patterns like observer, strategy, command, microservices patterns in Java. So like the saga pattern or the retry pattern. And the hexagonal clean architecture implementation. So basically the separation of concerns, to have the business logic, which is completely separated from external dependencies. And like you should have the interface from the service where it's gonna interact with the outside world. So, and again, I don't need to go very deep on that. You just need to have at least a grasp and an idea of how to do that. DDD, domain-driven design, solid principles. Like some solid principles, they are not very useful actually. Some solid principles, like for example, to use the least cloud substitution principle, sometimes it's not very useful. For example, when you're going to create a service and you need to create the layer of interface, it's, in my opinion, it's useless because you never use that with polymorphism. So anyway, sometimes we create lots of layers that really don't help much. And design for testability. So this is important, right? Like if your code is bad, it's really difficult to test, it's because your code is bad. So if you have a method that it will really have trouble to test this method, there is something wrong with your method. Like one way to see if your code is good or not is basically to see if you're able to test your code easily. If you're able to mock things easily, if you don't need to do like run through horrible loops and horrible nested ifs. So like if you have a code that you can easily test with unit test, it means that your code is great. So that's a very good way to see if your code is good or not. And one way to help on that and to make your code easier to read, I know that it's not all solid principles that is very useful, but one of the most powerful principles that the solid principle have is the single responsibility principle, right? It doesn't mean that you have to make your method specifically like with only one responsibility. Obviously, you're going to have to convert the DTO, you're going to have to do database operation. But the thing is that you're going to have an orchestrator method that, you're going to have probably the repository that will do a database operation. And you're going to have like a transformation of a DTO, right? Or a value object, whatever you want to call. So basically, the more you isolate the main functions of your system, the better to test, the easiest to test. So I personally like very simple. I personally like the API layer, the service layer, and the repository layer. In my opinion, you don't need to overcomplicate things. Like you just need 3 layers. Like you don't need more than that, right? For me, the service layer is the orchestrator layer. So like if you need to invoke a service from other business domain, just invoke this service. Like don't do lots of operations in one service. Like break it down, right, by business domains. I know this is a bit complicated to explain that, but I'm just giving you like from my experience what worked very well to create maintainable software. And you need to know about Spring Framework. In some companies, they will ask you only questions about Spring. So they're going to be asking you about inversion of control, like dependency injection, bin lifecycle. They might ask you those things. They might ask you oh, what is the dependency injection pattern? Can you explain that without Spring? How would you do that without Spring? And they might ask you about what's the difference between Spring Boot and Spring Framework, Spring Data and ORM integration, Spring Security, transaction management strategies, AOP. They might ask you, oh, why would you use AOP? And testing with Spring unit integration, end-to-end tests as well, Spring Cloud components for microservices. They might ask you, oh, what components you would use for creating a microservice with Spring. Okay, and what are the common interview scenarios? So the most common ones are, for example, coding challenges. They're going to be giving you some code challenges, very likely. System design question approaches. So they might ask you, hey, design Instagram. And then you have 45 minutes to design Instagram. So you need to know the strategies. Obviously, you want to design the whole Instagram in 45 minutes. You need to be strategic, right? And you need to design Instagram with the minimal features as possible. You need to make it very simple. So you have to assume that you're going to create Instagram with the simplest features. So, for example, you can say, oh, I will create the feed feature. I will create a story feature, not for many users. Like you assume the simplest. And, it's good to practice as well. Like if you don't practice, it's very hard to pass on those interviews because it's something that is very unnatural, right? How you would design a system in 45 minutes? Like if you don't have any practice on that, it's going to be very difficult to pass the interview. So that's why I recommend everyone to do mock interviews, because if you don't practice that, it's unlikely you will pass. So behavioral question preparation. So you need to know how to behave. So, and it's basic, right? Basically, you have to have the growth mindset and avoid complaining about the previous employers, right? Like those things will count for sure. So behavioral, like how the way you think, right? So they want to know if you're a person who is reliable, if you're a person who has emotional control, if you're a person who is good on what you do. So, and the growth mindset is one of the most important thing, because if you believe it can grow, then you have no limit. But if you have the fixed mindset and you believe you can't grow, and if you pass this message during the interview, people will say, okay, like you have uh, this fixed mindset, and I can't coach you. You're not coachable. Like basically, you need to be coachable. Like if they see you're not coachable, then it's bad. I remember I did an interview for Microsoft, and they really liked that I had the growth mindset. And really, I made lots of mistakes in the algorithm. I made lots of mistakes, and the interviewer even helped me a lot to solve the algorithm. And because I have this growth mindset, I passed in the interview. So, like obviously, it won't happen in every scenario, right? But it might happen. It might happen that they will consider a lot more like your behavior. Explaining complex technical concepts in a simple way. Like if you are going to the weeds to explain something complicated, then uh, then your communication skills are not good, right? And yeah, Jerome, we have to take chances, because like the worst thing we can do is to read those job requirements and be scared, right? And sometimes like it's HR who writes the job requirements and they have no idea what they are doing. So, and sometimes it's not that difficult, right? Actually, the most difficult things, it's what I showed you here, right? It's the fundamentals, like those things. The other tools are just tools that we can learn a lot faster. So, handling ambiguous requirements. So, we need to know how to make a decision of something that is ambiguous. Debugging and troubleshooting scenarios, that's very useful, right? When we have a problem in production, we need to know how to debug that. Code review best practices. So basically, be kind with your coworker, right? You don't need to be harsh, right? So, and if you are harsh in a coding interview, it's unlikely that your colleague, your coworker will improve their code. They won't. Probably they won't. And do retrospective. And so basically, sometimes they will ask you, "Oh, how was your experience with your previous project?" And you're gonna have to explain the experience you had in your previous company. So it many times they asked me during an interview, "Oh, how was your previous experience? What was the business? How was the systems? How were the systems connected? How was the database model?" So they made several questions. Sometimes they will ask you, they will test if you know what is a foreign key or primary key. It's very simple, but they might ask you, right? And so database and persistence. So the differences between JDBC and JPA, pretty much sure most of you here use JPA. ORM optimization techniques, transaction isolation levels, and this is important when you are doing an important microservice operation. Database indexing strategies for performance enhancement, N+1 problems. And this is a very interesting problem. There are several articles on the subject. And connection pooling. So regarding this problem, like I would recommend to not use bidirectional dependency on entities, because if you use that, things are going to become very complicated. I prefer just to make it simple, like just to do unidirectional dependency between your entities and run your queries like that. Because if you do bidirectional, you might go into a deadlock, and your chances to have the N+1 problem will be a lot higher. So there will be lots of problems. Like I like to make it very simple and just do unidirectional dependency. Like I don't like to use bidirectional dependencies on JPA, for example. Connection pooling implementation. So it's important to know, sometimes they'll ask you, "Oh, why would you use connection pool?" So NoSQL integration patterns. So you need to know at least the basics of NoSQL. Why would you use NoSQL over relational database? Caching strategies, L1, L2 distributed. And for testing strategies, we have JUnit, TestNG for integration tests, mocking frameworks such as Mockito and EasyMock, test-driven development workflow, integration testing approaches, and this is very important when testing our microservices. So only unit tests won't be enough. Performance testing methodologies, code coverage tools and metrics, test containers for integration tests, property-based testing. So there are lots of tests, right? Load test, stress test, so canary test, smoke test, and those tests are very important when you're dealing with microservices. So we have to know when to use them. It doesn't mean that you need to learn a whole lot of new set of tools, right? Because, well, you might use some tools, but like it won't be very hard, right? Because, like I said, the most difficult things to master is not those 1 million tools. It's this core Java fundamentals, concurrency, data structures, design patterns. Spring framework, yeah, kind of. Well, a framework is not exactly the fundamentals, right? But really, if you learn the fundamentals first, learning the tools will be a lot faster, a lot easier. So, build tools and DevOps. So we need to know about Maven or Gradle, CI/CD pipeline. So how we can optimize those pipelines, Docker and containerization. We need to know how to Dockerize an application, Kubernetes for Java applications, monitoring and observability. So there is Datadog, Prometheus in Grafana, there is Dynatrace. Lots of tools we can use in the market to see if the microservice is good or not, if they have issues. We also have many tools for performance profiling techniques like JMeter. JMeter is an excellent tool for Java. Log aggregation, best practices, infrastructure as code. So we have, for example, Terraform, CloudFormation. So those tools are good for infrastructure as code. I prefer Terraform because Terraform is cloud agnostic, and we can use Terraform in any cloud provider. CloudFormation is only for AWS, so I don't like it very much. And so, and for Java performance optimization, so we have some JVM tuning parameters, memory leak detection and prevention, profiling tools like JProfiler, and using some code optimization techniques is also good. String handling best practices, object pooling when appropriate. So we can also use benchmarking with JMeter, lazy loading patterns. So there are many things we can do for performance. And by the way, guys, I'm sharing this mind map at the end of this talk. So just to let you know, and we are almost there. We also have system design, and system design is one of the most common interviews you're going to have as an intermediate or senior Java developer. So basically, we need to know how to create scalable architecture patterns, load balancing strategies, caching architectures with Redis or Caffeine, message queue integration with Kafka or RabbitMQ, API design best practices. So how to design an API that will be enough for your business requirements. You need to know the difference between stateless and stateful services, event-driven architecture, high availability patterns. So how can you make your service, your microservice, resilient to failure? How can you make your microservice highly available? So all of those things, they might ask you. They might ask you, hey, how can I make your microservice highly available? What strategy you're going to use? You're going to use a retry. You're going to use, I don't know, saga pattern, whatever. So you need to know about strategies where you can make your services highly available and resilient to failure. Because with microservices, they will fail. Like most times they will fail. And how to practice for Java interviews then. So yeah, there's a lot here. For this structure, you can build some data structures as well from scratch, like hash map or array list. You can implement thread-safe versions of collections as well to help you learn more about concurrency, write customs, comparators, and understand the sorting mechanics. And well, this is kind of a nice to do. Like I don't think they would ask you to. Sometimes they will ask you to create an array list or a hash map, but it's not very likely. Still, a good thing to practice. And or you can. I actually recommend you more to practice on LeetCode, HackerRank, or CodeSignal. And I would recommend you to solve easy and medium algorithms. Focus on core algorithms like sorting, searching, dynamic programming. Implement solutions in Java, and you know, and I have this question sometimes. Oh, should I use Java because Python I use less code? Yes, you should use Java because you are more used to Java. So, and review solutions by others after solving. So, and you can review the solutions on AI. You can say, hey, AI, what's the most optimized way to solve this algorithm? But you have to do that only after you try it, like after 45 minutes at 1 hour, after 1 hour at max. Then you say, okay, then you're able to see it. But if you try like 10 minutes and just see the solution, you won't grow. Like it's very important that you go through the struggle when you're learning. And you need to really think of solutions, try different things. That's the only way you're going to build a skill. Because if you look very quickly to the answer, you're not building a skill. So Java specific coding challenges, like creating a thread pool is good exercise. Write efficient stream API. So system design practice, design Java applications on paper, and practice drawing architecture diagrams. I really like this StudyDraw. So like it's a very simple uh, app that you can create your microservice architecture. I'm gonna put here on the mind map. Review real-world Java architectures with Spring, Quarkus, etc. The theory preparation, like you can use flashcards if you're a fan of that. I personally like to use mind maps, like MindMeister. For me, it's really good. And but you can write about the collections framework, concurrency concepts, and there is this app here, apps Enki Web, and you can use those flashcards, and you can just take notes of lots of things you can to memorize. Do mock interviews as well. It's very important, right? So you can use the Challenger Developer platform. Some of my mentees from the Challenger Developer mentorship, they are doing mock interviews and they are practicing, they are growing faster. Or you can use platforms like Premp or interviewing.io. You can record yourself also explaining Java concepts so that you know if you're doing good or not. You can just open Zoom like it's a real interview, and you speak to Zoom to see like if you did good or not. Then you can see what yourself and give you feedback. Ask a friend for feedback as well, and time your responses to common questions, right? So okay, there are some questions here. So Jonathan is asking here if we should. So basically, Jonathan, we should focus on the fundamentals, right? All of those things are the nice to have. So what are the fundamentals? I showed you here. Core Java fundamentals, concurrency and multithreading, data structures and algorithms, design patterns and architecture. Like if you're able to solve many easy and medium algorithms, you're gonna do good. So, okay, and build a question bank. Compile frequently asked Java questions. So what are those questions? It could be a question regarding microservice, how to make a microservice reliable, or what is the volatile keyword, or like why would you use microservices? Why would you use microservices over uh, a monolith application? And you can also prepare examples from your experience. So, for example, if you worked with microservices, you can tell from your experience, hey, this is what I've done to, and that's why we opted to use microservices. And so this is very good to have a project-based practice, right? So this is a great way to grow your technical skills, which is to review open source Java projects and possibly even contribute to open source projects, identify code smells and refactoring opportunities, and practice also refactoring the code, right? Sometimes you see one opportunity to improve the code from an open source and you can do it. And it's going to also help you on your CV. Submit pull requests to real projects. So you can use that on your CV, right? When you submit a pull request and your pull request is merged, you can put that on your CV or on your LinkedIn profile. Build mini projects, and this is very good, right? Like if you're creating a real project, you are really building up your skills. You're not just watching random courses that is not helping you to grow. So one of the best ways to really build the skills is to create applications showcasing the Java best practices. So you can show that you are a good coder, right? That you care about clean code, you care about uh, having high quality software. You implement different architectural styles like hexagonal, clean architecture, etc., and many others, right? You add unit integration tests showing that your code, your way to build software is mature, and you document your design decisions. So you can also take poorly written Java code and improve it, apply solid principles, like the single responsibility principle is a very powerful one. Optimize performance, make it more maintainable. So you can make it more maintainable by reducing complexity, breaking it down, separating concerns, making the code like with lower coupling, right? And also to make the code highly cohesive so that they are very good at doing one thing. During interview simulation, use tools like SkeleDraw or actual whiteboards. SkeleDraw I just showed you. It's this tool here. Practice writing clean code without IDE. So it's good if you can like solve an algorithm on a text block on a notepad. So because in some companies They don't allow you to use autocomplete. And explain your thought process while coding, that's very important. And handle edge cases methodically. So always ask the interviewer about edge case scenario. So, for example, if you receive a string on your algorithm as a parameter, you can ask, hey interviewer, do we have the chance that this string will come as null? So that you handle this case, for example. And also set 45-minute timers for complex problems. So if you're solving an algorithm, put a timer to like simulate that you're in a real interview. So practice working under pressure and prioritize working, getting a solution for the algorithm, a working solution, right? Before optimizing. That's very important. You just, write the code that will work and then you think about optimizing it. Find a partner to code with, like take turns as an interviewer, as a candidate, and give constructive feedback. So by doing this exercise consistently, it's going to be easier to pass on those interviews. And what are the practical preparation tips? Consistent schedule. So 1 to 2 hours daily, mix coding practice with theory review, gradually increase difficulty of problems. So if the easy and medium algorithms are very easy to you, then go to the most difficult one. Create a GitHub portfolio, showcase clean and well-documented Java code, implement patterns and best practices. Always include README and explain the architectural decisions. Join Java communities, right? Participate in Stack Overflow. I'm pretty much sure that in your cities there is a Java user group. If there isn't, you can potentially create one. And follow Java experts on social media. I recommend you following the Java champions. Contribute to discussions about Java development as well. So you can go to the JDK, OpenJDK website, for example, and you can potentially contribute to the JDK. Mock debugging sessions. So practice finding bugs in Java code. And like if you are debugging something during the interview, explain the debugging approach. Use tools like JDB or Visual VM and document common issues and solutions. So I know there is a lot, everyone, but it takes consistency, it takes effort. It's not easy, but it's doable, right? Because like I said, the most difficult concepts here are those. And once you have the basis, it's easier to, actually database and persistence, they are also very important fundamentals, testing strategies, but build tools and DevOps or cloud computing. I know there is, a new paradigm there, but the most difficult is this. Still, it's this. Okay, so I have some questions here. Let me see. You're very welcome, Ahmed. Thank you so much. I will share the mind map. Yes. So yeah, actually that's a good idea. While I am um, responding to your questions, I will send the form here so that you can get the mind map. Just a moment. I'll just grab the link for you. Okay, the link's here. Okay, let's see. Okay. In the meanwhile, do you have any questions while I got the form here for you? I have some questions on the chat. I'm gonna answer to them, but I'm just preparing here the mind map for you. Okay, let's see. Perfect. Okay, I'm gonna send that to you. So I just sent here to you the weekly life satisfaction form. So basically, you can tell me here, Rafael, I want to learn this specific topic, or you can give feedback as well and tell me what I can improve. Let me see if this link is the correct one. Just a moment. Okay, let's try this one. Yeah, this is the link. Yeah, please try answering to this form. It's a very simple form, just so that you can tell me what can be improved and what you liked, what you disliked from this presentation, and you also get the mind map. After you fill out the form, you're gonna get the mind map. And in the meanwhile, let me see the questions. Yeah, the basic is very important. Yeah, and we often underestimate how important it is, the fundamentals, right? But actually, with fundamentals, it's how we become faster learners. Because if you see all the implementation from hash map, from array list, you're gonna see basically the implementation of in the array list, for example, the implementation of an array. It's an array. So, and for linked list, you're gonna see like the list connected by references. So you're gonna open the Java code and you're gonna see, oh my God, it is only all the fundamentals are here. Java is just implementing the fundamentals. So that's true. João is asking, are certifications essential? Not essential, but they help. Like it depends on your learning style. If you like certifications, and if certification is a way that you're gonna focus uh, on studying, then it's great. The only problem about certification is that if you focus too much on Java certification, for example, and you have an interview about algorithms, like it won't help you. Like depends on your goals, depends on your context. So certification is good, but it's not. It won't save the world. It's gonna be a nice to have. It's a nice to have, definitely. And it's even more like when if you're a senior developer. Like the more senior you become, the more valuable is your experience, not exactly the certifications. Okay, so Jonathan is asking, oh yeah, he's asking about the depth and breadth. So depth is about in the fundamentals, like I said. Okay, so Paulo is asking something here. Could you recommend some open source Java projects? Oh, actually, I think the previous live I did, I recommended basically all of them. So I have to check what was the weekly live, but I think it was the previous one. But basically, I recommend you starting with an open source project that you like. So, but the previous, I think I'm pretty much sure it was the previous weekly live. I talked about so many projects. If it wasn't the previous, it was the other one. So you can check on the can go to YouTube, can go to playlist from weekly lives, and the video will be there. It's something related to open source. So very good. So William is asking, how much time do you recommend prepare for an interview? It depends. It depends on your experience. It depends on how much knowledge you have. Oh, thanks, Joan. Yeah, thanks for talking about the Java Challenger Algorithms book. So it depends on your experience. Like if you are a senior developer and you never practice algorithms in your life, it's gonna take some time. It depends on your schedule. It depends on what you need to do. Depends in your personal life. It depends on many variables. It's very difficult, almost impossible to tell you that. Unless I have a one-on-one conversation with you, then it's different. Then I can assess like how many algorithms you can do, in how much time you can improve your skills. So, but basically it depends on your skills, depends on the whole context from your situation. Any other questions? Any other questions, or that's it for today? Sure, go ahead, Wellington. Evaluate him or on what? Mm-hmm. Oh yeah, so like I said, it is not only me. This is the general case, right? So basically, we analyze the capability of solving problems of the person, the technical knowledge, like if the person is able to talk about data structures, if the person knows what they are doing, right? And with some questions, you know if the person know what he or she is doing. And I also make sure that the person is not arrogant, right? Like we will have some, like, if the person is nice is something we consider as well. And the capability, the maturity on the communication style, right? So this is also important. So if they are able to communicate clearly and precisely, it's something uh, we also consider. So the main skill we're gonna be analyzing in interview is if the person is nice to work with and if the person is a good problem solver. Like, I don't care too much if the person doesn't remember about a specific function from a queue. Doesn't really matter. What matters is if the person is able to solve problems. Make sense? Great. Wellington? Oh, okay, great. Yeah, basically you have to show maturity in the way you communicate, right? So, like, speak confidently, like posture counts a lot, right? And also, like if you're doing a remote interview, like make sure the place you are is organized, or like if it's not, you can use a background. It's okay. It's fine. But like I've seen many developers using the camera where they are like here, like almost hidden, like it's horrible. Sometimes it's only their forehead is appearing, and like this is like for sure they're gonna be rejected, right? What kind of impression I would have from someone like that? So like those small things also count a lot. The resolution of your camera, if this resolution is too low, it will also pass a bad impression, right? So, but if the resolution is good enough, you can see you. That's great. And and the other thing as developers, and we already discussed that, I would avoid wearing smart shirt, because if you wear a smart shirt, it will look like a business person. Like you don't look like a developer. Like usually developers will either use polo or a normal t-shirt, plain t-shirt, right? So and yeah, but basically, in a coding interview, always ask before jumping to code. This is very important. Very, very important. Like always ask questions, ask about edge case scenarios, and also create a quick plan, like a small plan before coding. And explain your thought process while you create your plan. So, and if you have no idea, okay, so Paulo is asking here about the channel's name. Is Java Challengers. Okay, thanks, Jonathan. See you. Yeah, so basically, you you must behave in a way that you show maturity. Like jumping to code before knowing what you're doing, it's a junior attitude. Like for a junior, it would be acceptable. If you're doing an interview for a junior, then it doesn't mean like if you go through the code right away, it doesn't mean that you're a junior as well. It doesn't. It will only mean that you don't know the rules of the game because this is a game. It's a specific skill, and so yeah, there are some red flags that they might say, oh, because he jumped into the code right away, he he will fail. Okay, Ali, thank you so much. So, but that's pretty much it. More questions, Wellington? Ask a lot? Yeah, yeah, it's okay. As long as you ask questions that make sense, it's fine. Obviously, you can't ask the answer, right? You can say, "Hey, give me the answer." Like basically, you have to ask questions where you talk about edge case scenarios. If something isn't clear, you can ask. Sometimes the problem is not clear enough, and you have to ask, okay, what is this problem exactly? And like there is a balance, right? There is kind of a common sense. So asking too many questions, you might come across in the wrong way. Like if you're asking too many questions, it might look like that you don't know what you're doing. Like ask questions that you need to ask. Don't ask obvious questions like, oh, should I use this data structure? Like it's you who should give the answer for that, right? It's not the interviewer. You should ask questions only about the problem to understand the problem. And you come up with the solution. You won't ask about the solution. Hey, is this, can I use Q, for example? No, you're going to use Q because you know what you're doing. Like if you're asking about like the solution, it seems that you don't know what you're doing, right? So basically only ask questions about the problem to make sure the problem is clear for you. Once it's clear, then you create a quick plan, a simple plan with some comments, and then you jump to code. Make sense? Very good. Any other questions? Okay, so João is asking here, do you have any ideas or know any platforms of projects you create? I don't really know exactly. Well, there isn't a mentorship, man. You can check that. I can show you later where you can do that. Yeah. So yeah, there is. We can discuss that. And any other questions? Lots of questions. That's amazing. Very good. Sure, yeah. FYI. Mm-hmm. Okay, I think your audio broke up a little bit. Okay. I would say so because well, it depends on this technology. For example, if it's a lot different, like what what kind of language you are talking about? Ah, well, it's better to apply for a job because you're gonna have higher chances to pass. Like, and the thing is that you have to see if the company, if they ask, oh, you need 5 years of experience with JavaScript or Python. So, but usually it's fine because if you accept a project that you have to work with Python or JavaScript, you're gonna learn very quickly as long as you put the work, right? As long as you say, hey, I'm gonna focus on JavaScript, I'm gonna learn the basics, I'm gonna learn the things I need here. And usually the most difficult thing is gonna be to remember the syntax because the fundamentals you already know. So I would say go for it. Go for it. Yes, definitely. Just make sure that you tailor your CV to the position. Don't put that. Obviously, you can put that you are that most of your career worked with Java, but you can put also in your CV that you know Python, you know JavaScript. It's totally fine. It's more difficult. Definitely more difficult. Like, I wouldn't go this way. Right now, at least. Right now, it's gonna be a lot harder. Yeah, that's why it's good to have a long-term plan, right? So that you have your next step clear, and then the other step you try new things. So awesome. Any other questions? So yeah, it's almost. That's great, guys. So that's it. Thank you so much for being here. Congratulations on your commitment of investing in your career. I know that for Wellington, for example, it's late. It's the same time as me, almost midnight. For some of you guys, it's a bit earlier. But anyway, congratulations on the effort of being here. And Hansa also, it's late, right? I think it's 1 hour earlier, right? Yeah, it's 1 hour earlier, so it's still late. Very good. So thank you so much, guys, and I hope you filled out the form, right? Because then you get the mind map, and you give me feedback on what I can improve in the next lives as well. And you can also tell me about the content that you are interested in, right? Only you can tell me what's the content you need the most. Awesome. Okay. Thank you. Thank you so much. Bye, everyone. Cheers. Thanks. See you. Bye bye.